Okay, so now I want to talk to you about a arithmetic and geometric series. A series is the sum of a sequence. A series is the sum of a sequence. A sequence is a set of numbers that follow a pattern. So when we talk about a series can be either finite or infinite. Um, Finite meaning that it stops, infinite means it keeps going. So if you look here, a finite sequence, notice the terms are separated by commas, and notice there's an ending, whereas an infinite sequence, notice at the end you have the dot dot dot. So that's a giveaway that it's infinite versus finite if you have the dot 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 at the end, or if you have an ending number. If it's a series, notice it's separated by plus, it's separated by addition or subtraction, um, and the dot 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 still applies. Now, in your series, if you have a dot 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 and then a plus sign and then a number, then you are able to then find it. That means it is a finite series. If the last number is given, then that means it's a finite series. Then you'd have to do some math to find the the nth term, the term number. So that's if you're in pre-AP, you have to do that. If you're in regular, you do not have to worry about that part. Now, when you talk about a series, you talk about you use summation. Um, the Greek letter sigma for summation. You have your index, which is the letter underneath. And then you have your where you start. So on the bottom, this is your start, and on top, that's your end. Okay, this here is the sequence. So remember we said the series, and my iPad's not writing correctly, the sum of a sequence. And so the sum is sigma, and you have sequence there. Okay, so then you have a finite versus infinite. The way you tell the difference there is if there's a number, it's finite. Notice here on top, there's an infinity sign, meaning it just keeps going forever. So that's the difference there. Finite versus infinite if they give you the sigma. Okay. Okay, so here's just some information. An infinite arithmetic series always diverges. So remember, if it's an arithmetic sequence, it always diverges. If the numbers keep getting bigger, it's going to diverge to positive infinity. If the numbers get smaller, it diverges to negative infinity. Remember, if it's an arithmetic sequence, it always diverges. Therefore, the arithmetic series has to also diverge. If it's a geometric series, if it's an infinite geometric series, it's convergent. We talked about this in the last video for geometric sequences. If the common ratio is the absolute value of the common ratio is less than 1. And we put less than 1 but greater than 0. If you put less than 1, that's sufficient. Meaning it's a fraction less than 1. The absolute value of the common ratio is a fraction less than 1. On your formula chart, you'll find the equation for a convergent geometric series, which is S is equal to, which is this guy. S is equal to A sub 1 over 1 minus R. A sub 1 is the first term. R is the common ratio. And at the bottom here, after that, there's some information in reference to the series. It simply says that if the finite sum approaches a number as the term approaches infinity, then it's said that it converges. So in essence, it's saying as the term number gets bigger, bigger, and bigger, the sum approaches a number. And that's where we get the equation that S is equal to A sub 1 over 1 minus R. Okay. If the geometric series does not converge, then we say it diverges. Okay, here's just an example of finding the sum. It has the has it written out here. It says find the sum of the series. They give you a series. Notice that the start value of the series is 5. Okay, that's where you start, and notice the end value is 10. So all I'm doing is I'm going to plug in integers 5 to 10. 5, 6, 7, 8, 9, 10. So in my sequence, which is here, I'm just going to take 5 and plug it in for I, 6 and plug it in for I, 7 and plug it in for I, and so on. And they gave you that down here, showing you how it's written out, showing you if you were doing it by hand. Remember, if I were plugging that in my calculator, I would just do math 0. We use X instead of the letter they give me, and it's 5. The top number would be 10, and then we just plug in our sequence with X as the variable instead of the one they give. Okay, and then we hit enter, and notice we get the same answer as they have here. Okay, there's some special properties with summation. If you have a sequence multiplied by a number, it's the same as the number multiplied by the series. Remember, the sum of a sequence is a series. So this whole thing is a series. So it's saying this series is equivalent to the number being multiplied by the series. Also, if you have two sequences added together and you're taking the sum of those, it's the same as the sum of the first sequence plus the sum of the second sequence. Same thing if you have subtraction, it's the sum of the first sequence minus the sum of the second sequence. Okay, and then there's also some rules that we have in reference to if they give you specific terms. So for example, here you have the sum of cubes, simply saying that the sequence is a cubic equation. In a general, the parent function I cubed or K cubed or X cubed. Here's a formula you can use if you weren't able to plug it into your calculator to get the sum. You simply take the stop or the end number and plug it in where n is and get a answer. Here we also have a special, and this is when you're looking for the sum of a constant number, a number, say 3 or 4 or 5. For example, if I was in my math, if I plug this in here, I'm looking for the sum from 1 to 5 of, and we'll say a constant 6. Notice you get 30. Okay, that's the same as doing the constant times the end. Notice you get the same answer. That's what this guy's referring to. Here you have the sum of I, or the sum of X, or the sum of K. It simply says if you have a variable, if you have a linear equation, X, the parent function for a linear equation, X, it's simply saying that the this equation is equivalent to the sum of this guy. And then notice here at the bottom you have I squared. You still have a similar equation. You won't have to memorize the equation. You'll just have to know how to plug in numbers. Notice all I'm doing is I'm identifying that it is quadratic, and they want the sum of a quadratic. I simply take n and plug it into this formula, and I get my answer, and that would be equivalent to the sum. So here's an example. You want the sum from I to 10 of I squared. So you simply here's what it's equivalent to. So all you do is you take 10, and everywhere there's an n, you plug in 10, like they did here. You simplify it. 10 plus 1 is 11. 2 times 10 is 20, plus 1 is 21. And then you multiply the top, divide by 6, and then you get the sum. If you plug that in your calculator, notice you get the same answer. Okay, now these next two formulas are if you they give you the term number. So they tell you where you stop. Find the sum of the first 10 terms, find the sum of the first 15 terms, find the sum of the first 25 terms. They give you that, then you're able to use these equations here. The one on the left here is for arithmetic series. The one on the right is for geometric. Remember, you don't have to memorize them. You just have to know how to use the formula. So an example of an arithmetic guy would be a sub n is equal to 5 plus 2 times n minus 1. And they want s sub 10. Okay, so here in my equation, if they want the 10th term, remember the subscript tells you what they're looking for. I simply, wherever there's an n, I plug in 10. A sub 1 is the first term, which in this case is 5. And then a sub 1 is 5. And then a sub n is going to be a sub 10. So if I plug 10 into my equation, 10 minus 1 is 9, times 2 is 18. 18 plus 5 is 23. Okay. So I end up with 5 times 28, which is 140. Same thing, if I took that same information, I could do math 0 on my calculator. And its x is from 1 to 10 of 5 plus 2 times x minus 1. Notice I get the same answer, 140. Okay, the same thing works if it is a geometric partial sum. They give you, you just plug your a sub 1 in, plug your r in, and plug your n in, and get a answer. And here's just an example of an arithmetic series where they ask you to find the first 25 terms, and they just simply work out all the work for you there. Okay, the next guy here is more than likely to be something for pre-AP. So if you're a regular student, you can disregard this. Where they give you the sum, they give you the equation for a sub n, and then they give you the first term, and they ask you to substitute it into the formula and solve for n. Remember to keep in mind that your n has to be positive because it's a term number. Term numbers have to be positive. So there's a worked out there. Just kind of give you an idea. Shows you how to work that guy out there. And then here's an example of a geometric series. They tell you to find the sum of the first 10 terms. So your first term is 4. So 4 is inputted into my equation here. And then your r, you do right divided by left. So 2 divided by 4 is 1/2. 1 divided by 2 is 1/2. 1/2 divided by 1 is 1/2. So you plug your r in as 1/2 like we did here and here. And then your n is 10. So we notice here we plug, that's my n. Once I plug that in there, I can do it by hand if they require me to do it by hand. But if not, if they don't require me to do it by hand, then what I can do is, if I put an extra set of parentheses in the numerator and an extra set of parentheses in the denominator, then I can plug that in my calculator and get the right answer. So there's the work for that guy there. So here's the work if they give you a geometric sequence that has a first term of 4. It has a common ratio of 1/2, and they ask you to find, if given the sum, find the number of terms that you added up. And so it shows the work here on how to get that answer. So just to recap, remember a series is a sum of a sequence. If it's a sequence, the terms are separated with commas. If it's a sequence, the terms are separated with commas. If it's a series, the terms are separated with plus signs. If it's a geometric series and it converges, then you'll use the convergent geometric series formula in order to find where it converges to. If it's a arithmetic series, remember it always diverges if it's infinite. If it's finite, meaning they give you an n term, you can find the answer. If it's a geometric series where the common ratio is greater than 1, then in order to find the sum, they have to tell you how many terms to add up. And you would just use the formulas on your formula chart. Hope this is helpful. The last video is the binomial expansion, which we'll post.